Any sufficiently advanced technology is indistinguishable from magic.
Hey, everybody. Have you ever wondered what it's like to be an astrophysicist and get paid to answer some of the most interesting, exciting, fascinating, mesmerizing questions in the universe? First of all, is that true? Because I think a lot of people would love to have that as their day job, but as their night job, perhaps they'd be even more thrilled to be able to bring discoveries about the cosmos, including current events, happenings, astronomical phenomena, to the public, and to have an audience of millions of people, and to have a very thriving presence online on Instagram, on YouTube, on Twitter. And I'm speaking of none other than Dr. Becky, aka Dr. Rebecca Smethurst, who is my guest today on the Into the Impossible podcast. So first of all, I'm looking at you, Becky, and now I can verify it's really you, because I saw you got a little tick today. I'm sorry about your tick in most cases, but how's your tick? How's your tick?
My tick is great. Yeah, I've never thought I'd get a tick. You know, it's so weird that like the smallest of things can cause so much joy. It's so weird what we've put like currency in online, right? But I was like, a tick.
So we're of course speaking about the coveted, the vaunted blue check mark, or I guess it's a gray check mark or some kind of a check mark on YouTube, verifying that Dr. Becky is indeed who she is. She has surpassed the 100,000 subscriber mark. I am one of those subscribers. Actually, I have about 6 of those if you include all my kids and my wife and everything. We all have separate accounts, so we make up a substantial fraction of your fan base. Of course, Dr. Becky is an Oxford University astrophysicist. She's a popular YouTube personality, and she's the author of this awesome new book, which I love for very many reasons, Becky. First of all, I don't have that much time to read books, especially about like stuff in my field, which is astrophysics. I should be actually doing astrophysics, but this book is irresistible. You cannot put it down. It has a gravitational field that pulls on one's heart. And I want to start off with the book. What caused you to write this fascinating book? I'm talking about space at the speed of light.
Yeah, to be honest, I have no idea, because I thought I would never write a book, right? I read so many books. I thought I'd never write one, because I was told in high school that I was a terrible writer, right? Because I write the way that I speak.
Yes.
Which supposedly during high school English was not a good thing to my teacher, but apparently to a publisher and to a public audience, like that's what they love. So somebody reached out to me from a publisher company in the UK and said, you know, we love the stuff you do on YouTube. Like it's really easy to follow and like you make it fun. Like, have you thought about writing a book? And I was like, no. But they sort of convinced me to do it, and I actually really enjoyed writing it in the end. I think it was just, you know, coming up with the concept is that it's sort of 10 short chapters, and it's sort of like the things that if you were going to a dinner party of astrophysicists, say like me and you were having a dinner party with like, I don't know, 3 or 4 of your listeners, and they wanted to know like what are the 10 things that I should know about space, at least at sort of like the base level, so that I could, you know, get by in a conversation, you know, around a dinner table. Like that was the sort of idea, and it was, you know, really fun to just think of like, what are the things that I think would blow people's minds to read about? And, you know, they sort of wanted it in the style of Carlo Rovelli, if you've read any of his books,
yeah, of course.
You know, like the 7 Brief Lessons on Physics. And I was like, he's very elegant and eloquent. And I was like, I'm more overexcitable than elegant and eloquent. And so there's a lot of overexcitement in there. There's, you know, references to Mean Girls and Christmas films and all sorts, but oh gosh, it was fun to write.
Yeah, it comes through in the book, and you know, it's fitting that you mentioned the acknowledgments. In the acknowledgments, you mentioned that you were told by this high school English teacher that you weren't a good writer, or that you wrote the way you talk. And I wanted to actually start there because I think that's a huge asset for people like you to be able to communicate and to share things at the level. You know, I often get this, and tell me what you feel about this. And someone says, "Can you dumb it down for me?" What do you feel like when somebody says, "Can you dumb down? You're such a brilliant astrophysicist," and that is true. Everybody out there, you can look her up on Google. I mean, she is really, Becky. You're phenomenal output. You're a role model for both men and women throughout the world of astronomy. But what do you say to somebody when they say, "Can you dumb it down for me?" I want to get your take. I'll give you my take if you're interested.
Yeah. I really hate that phrase, dumb it
Me
down,
too.
because I think as what a science communicator you're trying to do is to not remove any of the complexity of the topic or whatever. It's just that you're trying to get it across in a way that someone will understand, right? Like you can take sort of like Einstein's theory of relativity and you could communicate between astrophysicists and being like, here's what it means, just by giving them an equation, and like someone would understand that because that's a language they're used to, right? Is the language of maths and tenses and vectors and all that kind of stuff you learn and if you do a degree in physics. But if you come across like, you know, Joe Jane public on the street, you're not gonna like give them an equation, but you're not dumbing it down by expressing that in different words at the same time, right? And so that's what I try and do is still keep the level of complexity. And like if I need, I'll build it up with you know, the concepts you need underlying that, but again in like the simplest way I can. And I've always in the back of my mind, I've always got my mum, right? My mum is like, you know, she did high school,
three
but that was
PhDs in astrophysics, and she's a relativistic particle physicist.
No, so she did high school and then left at sort of 16, which is the age you can leave high school in the UK, and that was it. But she's always been like interested and intelligent, but never educated, right? Because there's a difference between intelligence and educated, right? And I think I always think as long as my mum would understand what I'm saying, then I think I'm good.
When I describe you and I'm talking to somebody who's not an expert scientist, talking to my wife, I say she's basically like a drug pusher for the gateway drug of astronomy. You know, like you make it so, I mean, it's just your enthusiasm is irrepressible. And I think that does entice people. And then before they know it, they're like slipping down this, you know, wormhole of excitement. But you're not making it like, you know, I shouldn't use the word worm. I actually hate when people talk about wormholes and time warps and, oh, there's parallel universes. And I love to think about those things, but I'm an experimentalist and I like to deal with things that you can actually touch and divine and not have to come up with so much pure speculation. And what you do in this book is remarkable because you actually introduce, as the gateway drug pushers would do, you introduce things like galaxy zoo. I mean, these are very advanced topics in astronomy. And I want to ask you first, you know, what do you attribute the power of astronomy, uniquely so, to captivate the public? It's not like, I mean, our colleagues down the hall from you, you know, they're studying, you know, topological insulators and pneumatic fluids. And I mean, they're doing hard stuff, interesting stuff, I'm sure. But how come people don't care as much about that as they do about the stuff that you do?
Yeah, it's so funny that you describe it as sort of like the drug pushers, like because I've always called it a gateway science, right? And I think the reason is because we have the pretty pictures, right? The pretty pictures is what draws people in, and then people get so curious to know what's in those pretty pictures that they'll stop and listen. You know, we have like the perfect PR and marketing department just in the universe itself, right? Like all the things that we can observe with telescopes and everything. And I think that really plays into it. But I think it's more the fact that like people are so genuinely curious about what is our place in the universe, and you know, why are we here? These big philosophical questions that, you know, humanity has always asked, that I think, you know, physics and astrophysics are starting to be able to answer, you know, in the past sort of century or so. And I think that's what draws people in the most, is that it feels like these are the big questions. Right. And that's what really grips them. Once they've seen the pretty picture, you can then grip them and go, oh, but did you know like that this amazing galaxy that we've seen so many billions of years ago can, you know, tell us this about the universe? And that's the sort of mind-blowing moment, is that connection that they never necessarily realized. And I love it when you see people make that connection as well, and you see it in their eyes, and then I'm like, they're hooked for life now.
And when you think about the tools that we have, I agree with you 100%. I would say, you know, astronomy is the only subject that people are born with the equipment that they need to do it, namely these two refracting I just took one of them out with my poking myself in the eye. But most of us have two eyes, and there are little tiny refracting telescopes. And you talk about, you know, how astronomy evolved in this book. You give a very concise history and treatment of astronomy, but you really do take it up to the present day with things that were really unexplored until citizen scientists really started to engage. And I think that takes it one level above the gateway. into the actual practicing scientists. So for many years, the people have been doing great work as amateur astronomers and contributing to discoveries of comets and asteroids, things of that nature, and also doing great work in variable star research. But now we have things like Galaxy Zoo and these Aurora projects that you talk about. Can you say something about the proliferation of that? Because that, I think, is a little bit different than just, I'm interested and excited to know about this black hole at the center of the Milky Way.
Yeah, sure. I mean, I love what you said there about, everyone is born with the tools to do astronomy. First of all, I like to think of it as, the most sort of affluent areas in the world are actually the people who are at the most disadvantaged for doing astronomy, right? Because it's where all the light pollution is. And so it's this great idea that, people who are necessarily considered, less economically well off can enjoy this so much more. And I love the fact that, for those who don't necessarily have the night sky that they can enjoy, or for those who really do get so captivated by these questions and want to get involved themselves, citizen science is a way for them to do that, Okay, necessarily sort of going out in the garden, observing with your telescope every night, trying to discover an asteroid, because I think sometimes that is what drives people, that sort of desire to discover something. But the idea that, I need help doing my PhD, but there's so much data that, me and my colleagues, there physically isn't enough of us to go through it all. And so, the idea that 300,000 people around the world could help you with your PhD is incredible. And so I always, sort of laud citizen science whenever I can, because I've written papers where there's me and maybe like 8 collaborators from Oxford, Nottingham, Chicago, Minnesota, wherever in the world, Sydney or something like that. And then 300,000 other people, And it's like this work would not be possible because all of these people went to a website, they saw an image of a galaxy, and they were asked, is it spiral shaped or is it round and blobbish? Which is such an easy question, because image recognition is one of those things we can do from like a toddler, right? It's one of those things that we learn as children. And so getting people involved in that kind of science with the knowledge that, this science and this result and this discovery, wouldn't be possible without them, I think is incredible. And there's a great story out of the back of one of the projects. So one of the projects was asking people to look through planet data and the Kepler Space Telescope data. And it was basically sort of like, we're looking at stars, and if the star's brightness dips, there might be a planet there. So can you record for us if the brightness is dipping anywhere? And it was such a great project, and so many people got involved. The idea that you could discover a planet, around another star in our Milky Way, that was obviously, people absolutely loved that. And there did end up being someone who had discovered a planet that like computer algorithms had missed in the data. And he was a guy from the northeast of England, retired guy, and the media descended on his house, right? And we're like, why did you get involved in this like incredible project? Like, what was it? Was it the discovery that like drove you to do this? And he was like, well, there's only so much gardening you can do, and there's just not a lot on telly lately. Like, and it was just this retired guy, and they were like, do you think you've caught the bug? Do you want to catch another one? And he was like, no, probably not. I'll probably do something different now. And it's just that you can find so many different people that do it as a way to, spend some time on their commute doing something useful rather than make Angry Birds or something, I don't know. or perhaps maybe they find themselves in a position where they're not able to contribute to society in the way that they usually would, either through illness or an accident or something like that. And we've had so many testimonials from people just saying, thank you, it gave me purpose while I was recovering, to know that what I was spending my time doing was useful to someone somewhere, whether it was, classifying the shapes of galaxies or the shapes of craters on Mars or flagging where there are penguins in images from Antarctica. There's these huge raft of different citizen science projects. And it's a tool to get people into it, but it's also a tool to let them be involved in science themselves.
Yeah, I just want to correct you that Angry Birds is actually a high-class ornithological research.
Of course, I'm so sorry.
The ongoing war that we have between pigs and birds. So there are a lot of very cute and serendipitous connections in the book between things that have happened here in San Diego, and also your recent video, or not too recent, but over the summer, maybe it was, about women astronomers. So first of all, I think you're a collaborator with one of our former postdocs and proud former alumnae in some sense of UC San Diego, and that's Brooke Simmons. And so say hi to her.
I will. I have visited Brooke so many times in San Diego when she lived there, because why would I not make the excuse to fly to California whenever I could? We're like, we need to do this science. And I remember
still welcome back anytime.
I will. I remember the frozen yogurt shop that the physics department was right outside of, and I was like, leave me here. And then also they were testing the earthquake plates.
Yes.
Last time I was at UCSD, exactly right outside the physics building, and no one warned me. So as a UK person who has never experienced an earthquake properly, like in her life, like the whole building started shaking, and I was like diving under the desk. Like, is this what I'm supposed to do?
It's really fun to be putting together a detector, and then all of a sudden an earthquake starts happening.
Oh gosh, Brooke just looked at me so like, what are you doing? It's a test. And I was like, how am I supposed to know that? In California, I'm so close to the San Andreas Fault. I'm diving under desks and all sorts.
We did that for you. You know, it's like when I went to London, it was like perfectly sunny. There was no fog. And I was like, told my host at Queen Mary, can't you, arrange for some fog while I'm here? I mean, come on, give me the experience. So Becky, we wanted you to have that full experience.
Thank you. I appreciate it.
So we also have deeper connections in the sense that we've had my late great, unfortunately she passed away, but Margaret Burbage was here for many years. She actually founded the astronomy group. And she tutored a young scientist by the name of Vera Rubin and taught her a lot about the spectroscopic work that you talk about in the book. So I think it's a really nice thing to have this connection. And we also have, to my mind, one of the few, if only, physics departments that's named after a female Nobel Prize winner, in this case, Maria Geppert-Mayer, who was the only Nobel Prize winning female for 50, 60 years until just in 2018 when Donna Strickland won. So we have a very proud heritage of that. I want to ask you, if you're interested or comfortable, would you like to say anything about, being a woman in astronomy, how you see things changing or things getting better? Is the advent of technology like YouTube and so forth helping or hurting the cause of kind of increasing diversity and inclusion in astronomy?
Yeah, I mean, I am one of the lucky ones in that I have never experienced, at least face to face, the sort of the view that like I wasn't welcome anywhere I went, because of my gender. And I'm sure, I mean, there are definitely some everyday sexism things that you experience. Like I'm sure women listening will know from sort of any walk of life, whether it is in an academic department or outside of it. But I'm very lucky in the fact that I don't think I've necessarily been held back by perhaps someone in a position in power over me who is particularly sexist or misogynist, thankfully. But I'm very aware that there's this sort of prevailing view that like women like myself online are inspiration only to young girls. And in the sense that like, you have to see yourself to become it. And thankfully I was stubborn enough that I didn't need to do that to become an astrophysicist. I was just like, I just want to do it. So I did it. But I'm very aware that is necessary for a lot of people. But I'd hope that by getting in front of both, just any young people, that it shows them that women can do this, whether they are young girls or young boys. So I loved at the beginning of the podcast, you said, inspiration to both men and women everywhere. And that's really nice of you to say, because that's what I'm hoping to do. And also to just normalize the fact that there is this weird viewpoint in that you have to not be feminine to be in the sciences. You have to suppress that femininity to be, whether it's a physicist or an engineer or whatever it is, or a mathematician, and sort of not care about how you look or your nails or whatever it is. And I'm like, no, I want my nails to look nice colors when I'm typing away at my keyboard, like doing Python code to discover these mysteries about black holes and galaxies. So I try and just showcase that some more. And I hope that by being on YouTube, which is one of these platforms that is so young people dominated, that gets that message out there a little bit more and shows that there's nothing that's mutually exclusive with being a scientist. And that's my big mantra, and I hope that it can do that. I worry that the YouTube algorithm is very sort of circular in a way, and it sort of says, oh, you're logging on, you're an 18-year-old woman, you'll want to see all the things that other 18-year-old women want to watch, and even if they necessarily might be interested in space, they would never get like recommended it necessarily. And that's what worries me slightly.
What do your analytics, out of curiosity, as someone who aspires to the success that you've had on that platform, when you look at your analytics, what does it say? I mean, mine is like 95% women. 95. I wish.
I was going to say, how?
I wish, Yeah, what's my secret? Click here to subscribe to my newsletter and course. No, it's like 95% male, even though I've tried to have on, almost 50-50, and not because I'm trying to do so, but because, our profession is blessed by the fact that unlike a lot of other subdisciplines, there are so many successful, brilliant authors, and predominantly I'm interviewing authors, but I've got authors with African Americans, with men, women, etc., LGBTQ. I don't care, but I find it very hard to move that needle. And I'm not saying, oh, get rid of the men, I don't want them. But do you have any insight into your own demographics in your audience?
Yeah, so probably started off, it was similar, and the more it's grown, the more I think it has reached more girls. So on a good my highest percentage on a video has been about 30% women, but on average it's more like 15%. And that's the thing, like what you say, like, you don't want to get rid of the men, you just want to bring in the girls as well, right? You don't want to rob them of like this incredible, sort of like view of what our place is in the universe and that understanding of that, because, historically they have been more interested in other topics or whatever. Or historically been more interested in other topics because society said that they should be more interested in other topics, right? Because there's that like sort of, there's the often parroted phrase of like, oh, men and women just have different interests. And it's like, yeah, but did you consider the fact that like hundreds of years of societal oppression on women might have contributed to your view of the fact that men and women have different interests? Because most people I talk to, they're not bothered. They think it's really cool, whoever I talk to, right? So it's that kind of thing that barrier you're trying to overcome. And so much of that sort of stereotypical behavior is ingrained in a lot of the algorithms that now control our sort of, everyday life, from what we watch on Netflix and YouTube to what we listen to on Spotify to what we read on Amazon through the Kindle app or whatever it might be. It's like, even if we didn't teach these algorithms that, say, for example, the one that's come up so much recently with all the Black Lives Matter protests and everything has been like, I read a lot of sci-fi and fantasy. And it's like, you've read a lot of sci-fi and fantasy by white authors, therefore I'm going to just... show you some more. And I'm like, you want to, I don't care. But somehow that's been ingrained in sort of the algorithms, because it's learned that like this set of people like this set of authors and this set of people like this set of authors. And it's like, how do you break out of that? And I think it's the same issue in terms of like gender in the sciences as well, is how do we sometimes break out of those algorithms that are controlling a lot of what we actually, much content we actually view,
Yeah, and then there's also the overly simplified analysis. I had Katie Mack on, Astro Katie on Twitter, very prolific social media personality, as well as a top-notch theoretical astrophysicist. And when I had her on my show for my about 8 months ago, it was before her book came out, but she was talking about this problem and also talking about it as kind of a burden in a sense that I'll get to in a second. But she first said, there's always these oversimplified solutions like, oh, get a pink circuit board and then the girls will really love it. And it's like, she was at Caltech. Like, she doesn't need that. She wants the heart. And that's why I think what you do is unique. And in terms of you talk about current events, you talk about deep concepts, you don't water it down. I think you have to respect your audience. And that's what I liked about your book. You don't dumb it down. And there were things in there that I learned, even though I've been, doing astrophysics for, the better part of my, last 30 years. There's tidbits that are just like really curiosity stoking. And I think that's the real difference, is that there's a different level perhaps of curiosity that you have to stoke. And when you get these students, you have to get them at the right age and you have to nourish them throughout. I've been trying to lend a little bit, I have the square root of your followers, et cetera, so it's not really the same, but I'll just say, here's a guest post from an African-American theoretical physicist, and he can do the post, he can do the video. And I think it's a different format. Mine's more kind of interview rather than and conversation based rather than solo, which I think is an exceptional part of what you do so well. But I also feel like there's a burden on women and minorities too, from my friends that are African Americans, throughout the world or throughout the country that are in different branches of physics. They're always and constantly asked to serve on committees about the status of minorities, and then do outreach, and then do this and do that, and they get some support from the universities. But do you find it's almost like an added burden that female astronomers in particular that are you have a lot of research that you do. How do you find the time to do the outreach, the research, and also to do this inclusivity work that you do exceptionally well?
Oh, it's a massive juggling act, yeah, and that's the real issue, is that, you know, we're asked to be on hiring committees and, you know, all, and outreach committees and minority and diversity and everything, and it's so important to be invited and to have that seat at the table, but it's then that you're not left alone to just do your research. You know, the cis white man who's not necessarily wants to be involved in all these things and doesn't think it's their problem, is able to just carry on with their research, and then they have all of the great papers, and then they win all the prizes still, and it's just it's a circle again. And so it's a little bit difficult knowing that, and a little bit difficult juggling it. But, you know, I get the emails that remind you why it was all worth it, you know, from some 14-year-old kid somewhere around the world that's been inspired to become an astrophysicist because they've finally seen a woman do it and they needed that. And I'm like, brilliant. Or it doesn't have to be from a girl around the world. It can be from any kid around the world, you know, and it's just, or even, you know, someone who's 10 years into a career and has decided to change careers somewhere as well. You think, wow, that you can have that big of an impact in someone's life. It reminds you why you're doing all this and why you're doing all the juggling as well. And, you know, it's weird because we've been saying, I'm very, very lucky at Oxford to get to have like Jocelyn Bell Burnell just like down the corridor, who is the woman who, you know, discovered pulsars during her PhD, and, you know, her supervisor won the Nobel Prize for it, which is, you know, she doesn't seem to be, you know, angry about, but there's a lot of contention around sort of the academic community for, and, but, you know, conversations with her about how she's been saying, you know, back when in the 50s they were saying it will change because we'll get into positions of power and it'll change, and we're still saying that same thing. It's like the same rhetoric, and you just wonder what is it. And I think it is really sort of, I remember seeing a fantastic talk about someone who wasn't studying astronomy and had been dragged into this sort of diversity debate. It was, they were actually studying in the Netherlands somewhere, they were studying the gender balance in academia in general, right? And it was like the ways that we can fix it, and that was their research, right? It wasn't someone who was like gotten caught up in it and thought, oh, in my spare time I'll do this, like we have spare time, right? So they gave a talk about it, and what it really comes down to is two things. It comes down to those societal expectations of gender, which get ingrained in kids from about 7 years old. So if you want, you know, girls to pick physics and more boys to pick, you know, nursing or whatever it is that's the more traditionally female route, then you need to get through to them at 7 years old, not, you know, 14 or 16 or whatever it is. And the other thing is the way that we just treat careers in academia. You know, it's that sort of like the lone wolf scientist that, you know, takes 2 days off for the birth of their first child, and that's it, you know, in their life, and just cracks on with research. And it's like, no, nobody's life is like that now in modern day, like 21st century, right? Most people are living, you know, if they have a partner, it's usually dual income households. It's, you know, the father usually wants to take, you know, shared maternity leave with the mother, and we need to restructure careers with respect to modern day familial life, you know, however that might look for people, and career breaks and, you know, career gaps, and the freedom to go and do separate things while you do research and stuff. And that's what it comes down to. And until that changes, I think we'll keep saying, you know, oh, eventually we'll have, you know, more women in permanent positions and more minorities in permanent positions or whatever. And it's just like, there is bigger like issues that are stopping that from happening, right? That affect everybody. So
yeah, I want to turn, before we get back to the book and discuss the questions I like to ask all my guests. Let's talk about one of the papers I looked at. That's one of your higher cited papers that you're the first author on. So first of all, can you explain to someone who might not know what does it mean to be a first author? How does such things get chosen when you're working with people that are also very eminent, like Brooke and Christian, et cetera? How do you get to become the so-called first author? And we're talking specifically about Galaxy Zoo, the interplay of quenching mechanisms in the group environment.
Sure. Yeah. So that really is usually like, you know, whose idea was it first? Sometimes it's like, if it was your idea and you ran with it, then it's kind of your baby and you're the first author and you write it up. But sometimes it might be that you're a postdoc, you know, more senior, and you'll have an idea, but you won't have the time to do it. So you'll sort of say to a PhD student, you know, have you thought about doing this? Like, this would be a great project for you. And then they'll run with it, and then they'll be the first author. So usually the rule of thumb that I take is like, who's done the most work? Right. And then if it's really 50-50, then whose idea was it? That it's their baby then, right? And and therefore like they're going to write it up. So this paper that you're talking about was part of my PhD. And so like the idea for my whole PhD obviously came from my supervisor, because that's what happens in the UK. You apply for a specific project, and sort of the project is then yours to do what you will with it. That's the idea, is that you take it in whatever direction you like, because it's independent research, obviously a PhD. So this was like the last project, and this was really like, I want to do this with this data that we have available. And so that was like why it was my sort of first author paper. And everybody else who's listed as an author is like my collaborators who, you know, during the process, I would go into their office and I would, you know, turn up with a plot, and I'd be like, this is a plot I've got, and I'm thinking it's telling me this, but like, what do you think? And I would just like bounce ideas off them, and we would, you know, have sort of like a back and forth. And it's one of the things I love most about my job, to be honest, is just making a plot and wandering into someone's office or someone's Zoom call at the minute and just be like, what do you think? And we just bounce ideas back and forth about what it could mean in terms of like the big picture of the universe. Like when you put it that way, it's like mind blown. And so like that's what it really means, right? Is that you're the one like leading the interpretation, and you're the one making the plots and writing the code and really doing the grunt work.
And so this paper in particular is interesting to me because it suggests sort of a decently long time scale, you know, comparable to the age of the sun, for example, for objects at a decent distance, that you kind of cross-correlate these different spectral and energy regime data from Galax to SDSS, et cetera. So this what would you say is the most surprising thing? Was it related to the time scale for this quenching? First of all, what's quenching?
Yeah,
what does it mean? You know, it's hot the day in the summertime, you go down to the pub, or what does this mean?
Main focus of my research is this idea of quenching. And it's this idea that galaxies are these islands of stars, you know, hundreds of billions of stars, right? And they have gas available to make new stars. But as like other stars die, you know, over the sort of millennia, well, not millennia, maybe millions of years, I guess, to billions of years. Mm-hmm. And so the question is like, if a galaxy has a constant supply of gas, will it just keep on forming stars, right? Or if you cut off that supply of gas, what's going to happen to it, right? Is it going to stop forming stars? Will it stop forming stars very, very quickly? Will it stop forming stars very, very slowly? Like how fast is it going to use up that remaining gas? Or how fast is it going to get rid of that gas? And therefore, what processes are actually doing that, right? Like, and so one of my main focuses of my thesis was understanding how like supermassive black holes could contribute to this. And one of sort of the ideas behind that was that, well, it depends like what environment you're in. Are you in a very dense environment surrounded by lots of other galaxies, or are you in a very like underdense environment where they've been relatively left alone? And so I wanted to sort of piece this out of what was going on so that I could understand better what was going on with the black holes. Like, what role did the black holes play? I couldn't piece that out until I knew what role the environment was playing. And so I did this big study on sort of like, okay, let's take into account how big the galaxies are, how massive they are. And let's take into account how many sort of nearest neighbor galaxies do they have. And let's take into account what shape the galaxy is as well, because the shape of the galaxy, which is where the sort of classifications from galaxies do come in, really sort of tells us what's happened in a galaxy's past that we can't necessarily see in any other sort of clue about the galaxy. So, for example, if a galaxy has a sort of big blobbish shape rather than a spiral shape, we'll think that it's had a merger with another galaxy at some point in its history. So that tells us a lot too. Mm-hmm. And so what I was trying to do was sort of by saying, okay, from how bright these galaxies currently are in the UV light, which is probes, you know, very recent stars that have formed, to sort of more optical reddish light, which probes sort of the older generation of stars. Can we unpiece what rate the galaxy is forming stars at? Is it like top rate? Is it slowing down? Has it slowed down very quickly? Like, what's happened here? And so one of the surprising things, yes, was how slow these processes might actually happen, especially in galaxies that have been left alone, because we sort of thought galaxies left alone, they'll just keep happily forming stars, you know, as contently until something happens to them. But actually, they can sort of shoot themselves in the foot and like do things that mean that their gas is used up, you know, from stuff that they do internally to themselves. But that can happen so slowly, and that can get confused with the sort of stuff that black holes tend to cause as well, which is really intriguing. But I think the main thing that came from that paper was that, you know, everyone for maybe the past 20, 30 years that have been studying this have been sort of saying, you know, what one mechanism is causing this, right? For this type of galaxy, then, you know, this mechanism is the one thing that makes it stop forming stars. And for this type of galaxy, there's this one process that makes it stop forming stars. And from what I concluded, it was just like, actually, there's this like, I don't know, conspiracy or cohort of quenching processes that are all like collaborating and working together and all affecting a galaxy at some point in its life to sort of keep it, you know, from forming more stars. And, you know, it's not just one thing. They're all in cahoots with each other, basically. And I love this idea that, you know, this is probably why we're struggling to find evidence of like black holes stopping forming stars, which theory says they should do for ages, and we're still searching for observational evidence of it. And that's one of the things I'm doing now. And it's like, why is it so elusive, this evidence? It's probably because it's mixed up with all this other stuff.
Why is it so hard to find about these things that existed billions of years ago and are located billions of, it should be so easy.
Yeah, I know. And yeah, it's just not, because there's just so many things that have just got in the way, I guess, and neither sort of masqueraded as this effect or maybe even drowned out the effects of this other thing we're looking for. And so it's a really interesting piece of work, actually. I really like it.
It's a very readable paper. I looked at a few of the papers that had to do with feedback, and, you know, have to look for my my former coworker Brooks' work and the interplay between both the interaction that you guys have with the data, not only from Galaxy Zoo and the citizen science. That, of course, is a story in itself. Literally, I mean, Christian has his stories about that. But the work that you and Brooke do on AGN and black holes and the interaction and the feedback mechanisms and star forming, I mean, these are the biggest topics that anybody can study. And there's so much more left to know as you talk about the different knowns, unknowns, et cetera. I always ignore the advice that people say, don't judge a book by its cover. And I always judge books by their cover. And now I also judge books by their weight, their mass. And this one's so nice because it's so portable. It literally fits in a big enough pocket. But tell us about the cover, the title. What does it mean? Who came up with it? How'd you think about it? What does it mean?
Well, funnily enough, it's got two different titles in the UK and the US, which is frustrating
happens,
as someone who's like a global, you know, sort of social media presence.
Right.
But yeah, so in the UK was where the first title was sort of like Space 10 Things You Should Know. You know, it was based on the idea of 10 short essays, and it was sort of very concise. And in the US, they thought they wanted to go with more of the idea of the fact that it was a quick read, you know, that it is so short and that it's very digestible. And the main thing I didn't want to do with this book was make it so long that it put people off, especially beginners who are new to this kind of topic, but we're still interested, but we're like, oh, that's too smart for me and whatever. And it's like, no, that's ridiculous, right? Like, it's written for you know, anyone to enjoy, but particularly the fact that it was sort of like you can dip your toe into this with a quick read. And so they really like the idea of space at the speed of light. You know, it's kind of a little pun of sort of like, you know, you can read it really quickly, the fastest speed there is almost. So, and also that I speak really quickly, and I'm known for speaking quickly. I guess it sort of has a pun on that too. I really like the subtitle of the book, though. It's 14 billion years for people short on time, right? It's like the history of the universe, the big things in the history of the universe that you know you want to find out, and sort of like you say, like yourself, you know, not much time because you've got so much other stuff going on, but you're still interested. The cover, I think I love both covers. The UK cover is shiny, which it just appeals to my magpie tendencies, which I love. You know, it's like blue and shiny. But the American version is, or the North American version, I should say, because it's US and Canada, is like blue and coppery color.
Yeah.
And like, I'm a millennial and I fully embrace the millennial, and I'm just like, look at how beautiful it looks. It looks beautiful on a coffee table, especially. And like, I don't know if you listeners will be able to see behind me, but I have a blue wall, you know, with like copper accents. It's very like millennial Pinterest. And I love it so much. And I love the fact that it can be this like beautiful piece, like on someone's bookshelf as well. It will really add to that,
and
which I like.
It's extremely readable. Also, the illustrations are just delicious.
Yes.
Actually, literally delicious. Look what I'm using. This is a hot sauce that I enjoy sometimes. It's called truff. So I actually was using it. But the illustrations are delightful. Can you say a couple words
Justin
about
Van Genderen.
Yes.
Yeah, Justin Van Genderen did those, who is an incredible artist. And what the vibe was for those illustrations was sort of these like the NASA like vintage posters that they made for sort of
Come
like
to
the
Kepler
exoplanets.
51b,
Yeah,
right? Which you talk
it was
about.
that.
Yeah.
Yes, exactly. And like I that was the sort of the vibe, was that it would be both scientifically sort of accurate in the sense of a data visualization, but still beautiful in the fact that they were artwork, you know.
Yes.
And like I'm hopefully going to get one of them framed and stuff, which I'm really excited for. And you know, it does have that sort of vibe. And also one of the things I love about it is that all the illustrations are blue and red.
Yes.
You've noticed that they're all blue and red.
Yeah. It's the aesthetic.
And
Yeah.
Yeah. And the idea is that it's sort of blue shift and red shift.
Right. Mm-hmm.
Yeah.
And you actually talk about Doppler and the Doppler shift as well.
Yeah.
In a very, very readable explanation of that. Thank you.
Yeah. So blue and red for blue shift and red shift, and sort of that sort of spectrum of light across the universe was the idea. And I loved that play with color. I thought it was great.
Yeah, it's really delightful. And you know, another fun thing about it is, and this is no disrespect to your massive, wonderful paper, but that paper is about 18 pages, give or take, that we just discussed about quenching. And it took me as long to read that as to read this entire book, you know, where I check off on my list of books read in 2020. I don't check off the papers, but the thing that appealed to me so much, we already talked about the acknowledgments and how you acknowledge kind of this high school teacher. And what struck me in the paper, I just have to mention it, so like you acknowledge an anonymous referee. I mean, that is very, to me, that's very worthy of respect, because a lot of times we just assume and we cultivate this image that we astronomers, you know, we know everything, we can do everything. And in both cases, both your teacher was wrong for underestimating you or not valuing this skill set that you have. I always say, like, I mean, you're kind of a stand-up comedian in some ways too. And that's actually a very difficult skill stack, because you have to know a little bit about persuasion, a little bit about sales, you know, the ability to sell an idea, aesthetics, as we were just talking about, artistically. But, you know, one thing that's not really taught is sort of, you know, how do you put all those individual skills together? And we know many astronomers who are, you know, can do more calculations or have done more observations, and they're so superhuman, but very few people can combine those skills together. So I really appreciate that you do that. You write in an engaging fashion, both in your, you know, in your research work, which is very digestible, but in this book as well. I call it in my review, I forget what I said. I said it's as brief as inflation, but teeming with information and inspiration as our galaxy probably teems with life. Nice. So I want to finish with a couple questions that I ask all my guests. You call these, you know, deep questions. I agree with you. It's early here, but it's late
we're getting
there.
deep.
Maybe you've quenched yourself at the pub already. I don't know.
Sure. No, not quite. I wish.
But you know, so I ask these questions to really get a sense from my guests and give a little bit more of the personality. Of course, you were, you know, a well-known person, but I asked them, you know, if you were to leave a will, not a material will with your vast wealth and your presumably, you know, your don't they give you at YouTube some kind of plaque or something with unobtainium built into it? No, copper for you. So you're not going to leave that to anybody. But what wisdom or, you know, influential piece of advice or something would you want to give to people in the future in the form of what we call a ethical will?
Yeah, I guess where my mind goes with this question is like a sort of dystopian future where like all knowledge has been lost. Like, what would I want to pass down in the hope that, you know, they could rebuild, I guess, or something, or like rebuild the knowledge base that we once had. And my brain went to this sort of the fable. What is it that you know, give a man a fish and you feed him for a day, but, you know, teach a man to fish and he feeds himself for a lifetime. I was sort of like, what's the astrophysical knowledge equivalent? That was where I was trying to go, to be like, you know, what is the thing that I could pass on? And I think I've decided that it would be the knowledge of how to like build telescopes. So something like the Hubble Space Telescope or the Very Large Telescope or something like that, in the hope that if you give them that, then they just rediscover all the things that we know anyway, right? Because they'd be able to look out and see, you know, the stars in the Milky Way, and then the island universes of galaxies outside it. As sort of, can't call them island universes, right? We know them are galaxies of hundreds of thousands of stars, hundreds of billions of stars in themselves. but then also that they'd be able to see those galaxies recessing, and they'd come to the conclusion that the universe started in a big bang. And then all of the sort of benefits that we've then got in terms of like astronomical research from, digital detectors and image analysis that's fed into medical imaging, and, Wi-Fi from astronomers getting so frustrated that it's taking so long to, literally so much in smartphones has come from astronomy. And everyone's like, what's the point of doing astronomy? And you're like, well, yeah. So I think it would be that kind of stuff, right? And then there'd be so much that would come out of that from giving them telescopes. Yeah. I think that would be the thing. It's like, I don't want to tell them stuff. I want them to figure it out themselves.
Yes.
In my ethical will.
That's exactly what you do in your teachings online.
Oh, yeah, I guess I never thought about it that way.
Yeah, you stoke the curiosity, and once you teach the person curiosity, then he or she can take it from there. And sort of that's the fishing versus teaching to fish. And of course, I, as a telescope builder, very much appreciate you astronomers, saying things that are nice about those of us who build telescopes, because often
we won't be able to do
thanks for building us that thing in that dome over there. But we'll take it from here, Keating. We don't need you anyway. Next one is also kind of about the future, but it's more about sort of the biggest thing that you associate with accomplishments of humanity, perhaps, and maybe it's related to what you just said. And this is something that a civilization wouldn't necessarily need to know, like how to build a telescope, because they're going to discover it, basically 1 billion years from now on a monolith, on the moon's surface or on an asteroid. And this is kind of like in Sir Arthur C. Clarke's 2001 Space Odyssey. These monoliths are kind of meant there to be discovered at certain times. And some people speculate, you talk a lot about life in the universe, that, the moon, the surface of the moon, or these Trojan asteroids or whatever, would be good places to put alien civilizations could have put messages there for us to find. And I guess what aspect of humankind, it sounds like it would be something astronomical for you. Do you think are you most proud of? There was a famous picture when Einstein died in 1955, I believe. Time magazine put a cartoon out, and it was a picture of the planet Earth with a giant billboard, and it said Einstein lived here, and it was pointing to. What do you think is like sort of the greatest accomplishment? And it doesn't have to be astronomy. It could be literature or whatever you do outside of astronomy.
This is the thing. I've been trying to think about this, and it's so difficult because I don't feel like I'm a good enough judge outside of like astronomy and astrophysics of like what is, the most important knowledge that we have, right? Because it's not my field, and I could pick something that would, not be. And so I feel like I only have the, the gravitas, if you will, to decide what it would be in astronomy or astrophysics. And so my brain went to sort of like the idea of Leavitt's law, named after Henrietta Leavitt, of Cepheid variables. If you have Cepheid variables, you can use them as these sort of standard candles and figure out distance in the universe. And so if you have that, it's sort of the bottom rung of the distance ladder, we call it, right? And you can work out the next thing that needs to be calibrated based on Leavitt's law and all this kind of stuff, and on and on and onwards. And I was like, maybe that would be the thing, giving them the first step on the ladder, and then they again, like, teaching them how to fish kind of thing. It would then they'd be able to take all the steps in the ladder themselves. But in trying to think about it in terms of like all of human accomplishments ever, like like it's so hard. Like go back to the wheel. Like I presume they would have the wheel. Anybody who's going to discover this on the surface of an asteroid. So I almost feel like, in a way, if I'm thinking about some either future human civilization or ancient or, future alien civilization that's going to discover something that I can leave on an asteroid, if they found it on an asteroid, they're going to know more than I am. Right. And so it's almost like arrogant of me to assume that I could know something that would be valuable to them.
Interesting.
That was my thought.
Would
fun. There be anything like penicillin? Like, I don't know, for the chemical formula for penicillin, would that
cure
be helpful
for COVID?
For them?
Please find that right now. I asked Ann Druyan the same question. She's the late great Carl Sagan's widow, and she actually did it. She actually put her brainwaves on the golden disc that was mounted to the Voyager 1 spacecraft. So she's like, I've been there, I've done that. But she actually told me some other things, so I'll leave that as a teaser for you to check out on my interview channel with her. Last question is maybe easier and doesn't have anything to do with astronomy necessarily, but this is kind of going, now we're going back to the future. No, we're going back to the past. We went too far into the future. It's we did it. What do you think you would tell the 20-year-old Dr. Becky or pre-Dr. Becky? What would you tell her? A piece of advice that you once, the name of this podcast is Into the Impossible, and it derives from Sir Arthur C. Clarke's third law, which is the only way to see what is possible is to venture out into the impossible. So what did you think was impossible, perhaps as a 20-year-old? Or 30-year-old, I don't know. I actually don't know how old you are. It's not important.
Just turned 30. I'm getting over it slowly.
Yeah. Well, I would trade places. I always say it's better than the alternative, not getting older. So tell me, what would you tell yourself as a 20-year-old that you wish you knew, but you found out only because you had the courage and the fortitude to go into the impossible?
Yeah, I would tell her that nobody, no matter how successful or put together or, career-wise, whatever they have, nobody had a plan for how to get there. That's what I would tell. It seems like, the very organized and successful people had this like roadmap that they were following, right? But I feel like there are people now that would consider, what I do I consider it a dream job. Like literally I'm doing research and I'm doing YouTube and SciComm and then people like it and it's great. It's literally the dream job. And I'm like, I didn't get here because I wrote out a 10-year plan at 20-year-old or a 5-year plan at 20-year-old. I got here because it was just one decision at a time, that every decision I made was for like, yeah, that sounds fun. Let's do that. And that meant that I made mistakes, and mistakes are totally okay because how else are you supposed to learn, right? So I didn't necessarily go into the impossible, but it went into the unknown and ended up here, right? So when I finished my university undergrad, I was like so lost of what to do, right? I loved school and I felt bereft when I left school, right? And so when I got to university, I was like, phew, 4 years at least. Now I like this is fine. And then at the end of that 4 years, I was like bereft again, not knowing what to do because I just love learning and just these holes of learning. I was just like, I want to do this for the rest of my life. And I didn't realize at the time that going into research meant you will still be learning for the rest of your life, right? Because you're not necessarily being taught it anymore. You're the one figuring out the answers. No one's telling you the answers anymore. You're literally like writing the textbooks.
It's not like solving harder homework problems, right?
Exactly, right, yeah.
It's problems that might not have an answer. I mean, you didn't know if you'd find this answer, these quenching questions until you actually did it. And you did go into the, think about trying to explain that to your great grandfather, many decades ago. They couldn't even comprehend it. So in a way, you did go into the impossible. And thanks to Arthur C. Clarke's first law, which is any sufficiently advanced technology is indistinguishable from magic. I want to thank you for the magic that you do and for writing this little slim book that I could give to anybody now. And someday you'll have to sign it when you come back to get some yogurt.
I promise.
I'm inviting you here to get some yogurt across from my
not
office.
A thing in the UK.
Oh my God. There are many privations, but maybe none so much as that. Becky, thank you for being an inspiration to millions around the world.
Thank you
for the awesome science that you do that keeps us so interested in the communication of that science that helps us who perhaps, are aspiring to do exactly that, know what path to take and to be someday perhaps get a little tick just like you someday. That's I want to have a tick just like Becky, Dr. Becky.
Okay.
Dr. Becky, thank you so much. Have a wonderful evening over there. And I hope to see you sometime soon in the real world.
Sure, definitely.
Any sufficiently advanced technology is indistinguishable from magic.
If you enjoyed this episode of Into the Impossible, please subscribe, comment, share, rate, and review. For a chance to win a free copy of our most recent guest's newest book, send a screenshot of your review to info@imagine.ucsd.edu. We appreciate hearing from you and are always open to your suggestions for future episodes. For more information, go to imagination.ucsd.edu. Find us on Twitter @ImagineUCSD. Watch us on YouTube, listen on iTunes. Into the Impossible is a production of the Arthur C. Clarke Center for Human Imagination in the Division of Physical Sciences at the University of California, San Diego. Eric Veary, Director. Brian Keating, Co-Director. Patrick Coleman, Associate Director. Produced by Stuart Valco.